All right, so this week we should really discuss your third part for the inheritance. That would be the final part for inheritance about polymorphic method parameters or polymorphic return type. As usual, before I dive into the technical context, let's now take a look at some announcement just to bring you up to speed about what's happening in the course. Your lecture week number 10. So that's still relevant to inheritance, but there's really no new concept that's being taught. You just have to learn about a few keywords. Okay, I just mentioned that quickly. So one is about the abstract classes. So you definitely have to learn about the abstract keyword in Java. Either you can declare a method to be abstract, or you can declare a class to be abstract accordingly. Right? I'll let you study the detail. And number two is about the interfaces. So you will learn about two new keywords, interface and also implements. So these two topics are definitely relevant to what you learned about the theory or practice, in the inheritance lecture. It's mainly just for reinforcing your understanding about inheritance and also maybe some type, not too much about typecasting, but you can definitely apply the concept as well. And number three is about generics in Java. Okay, let me just emphasize that for this lecture here, unfortunately, I was running out of time when I was recording the lecture, so I only cover up to slide number 9, I believe. You can check your lectures page. So we actually spoke about what if you don't really use generics and what will be the drawback for the design. I only finished that part in the week number 10 lecture, but in week number 11, I will carry on to talk about how you can use generics in Java. But for your written test number 3, which I will speak about briefly today, I just released a study guide about written test number 3. And in that case, you only have to study up to slide number 9, just to emphasize. Okay. For your lab number 4, okay, I'm pretty sure you have been working on that. Maybe you have finished already, but just remember the deadline will be Monday next week, November 22nd. I believe it's 2 p.m. EST, just as usual. Right? If you got any trouble, let me know, and then we'll sort it out. Okay. And for your written test number 3, it's going to happen next Thursday and Friday, right? If you look at the course calendar, let's take a look. And then I'll mention briefly about the coverage for your written test number 3. If you go to the course semester calendar, okay, you will see that we are now actually we are November 17th, so we are here, right? As I said before, these 2 weeks we don't really have anything due or actually tested for you, so you definitely want to take that as an opportunity to catch up with the lecture. But so now you are actually got your written test number 3 coming, so hopefully that will really motivate you to do some more study about the lecture. Okay. The written test number 3 schedule will be next Thursday and Friday, November 25th and 26th. Sorry, 25th and 26th. And it's going to cover everything until week number 10. Let's just go look at the guide to be a bit more precise. So if you go under week number 10, okay, over here, you will see a guide for written test number 3 over here, right? Open that. The policy will be identical to what what the policy for written test number 2. So you will still be given the extended time, 30 minutes, right? The same as before. And the time limit is really strict, so please make sure you actually submit your answers before the test period ended. Okay, it's going to be, again, 24 hours window between 25th and 26th of November, next Thursday and Friday. Okay, what about the coverage? The coverage is going to be whatever we cover in week number 7, 8, 9, and 10. So 7, 8, and 9 is about the inheritance. And week number 10, which was just released yesterday, is about abstract classes, interfaces, and also the first part about generics, right? Up to slide number 9, right? Right, just make sure you study them and also understand all the examples. And then if you got any doubts, reach out to me. You know how to do that. Okay. And for example questions, I'll try to make some available, like for your written test number 2. I'll make some available by next Tuesday. So after I release them, you still got about 2 days to actually practice and just to get familiar with the formats. But your safest bet is to really study everything that's required by the written test. Okay. All right, so that's about the announcement. Do you guys have any questions related to the course before I dive into the technical contents? Anyone?
Yeah, I do.
Go ahead.
I had two questions that I've been trying to answer for myself, and I think I've answered one of them. The first was when we're talking about descendants, we say that they must
Oh,
have a
sorry, it's technical, right? So I'll save that
oh,
for,
my
yeah. No,
apologies.
sorry.
Okay.
You'll be the first one once I move to that stage.
Okay.
Just before you ask, any administrative questions, guys? If no, I'll move on to your fellow students. Okay, here we now. Okay, go ahead, please. What about the
Sorry.
descendants?
So yeah, we say that a descendant must have a strictly greater expectation than its parent, and I
Mm-hmm,
was
mm-hmm.
thinking that it would technically be strictly greater or equal to, but I also realized it probably doesn't make sense to declare a descendant that adds nothing new from the parent. So is that why we say that a
Mm-hmm.
descendant must have a strictly
Good
greater
question.
expectation than its parent?
Good question. Let me try to address that maybe more completely. Let me just say, for example, let's just say you have a parent class called A. Okay, just make it a little more symbolic. And then you got one subclass or descendant class, let's say called B. Okay. Let's say over here for A, we actually declare some mutator, let's say void, let's say MA over here. And then you may take some parameter. Let's just make it parameterless, like that. And then it is possible when you actually first develop B, you simply say B extends A. As soon as you have done this, right, from the compiler's point of view, B has strictly more expectation than A. Okay, so we are more talking about this in perspective, meaning that it's going to be we're assuming that these two classes may be subject to revision at some point, subject to extension. Okay, in the long term, in the long run, subject to extension. Okay, let me elaborate on this a little bit. Give me a moment. Subject to extension. Let's say at this point, if you think about the expectation for A and B, informally you might be thinking that okay, MA is actually inherited to B. Let's say we don't decide to actually overwrite MA, and also we decide not to introduce any new methods to B. So it seems like A and B have the same expectation. It seems like, but from the compiler's point of view, they don't care, right? Whether their expectation is actually equivalent or maybe one has more expectation or not. They only consider that in the future, at some point, it is expected that the descendant classes should actually introduce some new methods, even though they don't at the moment, but the compiler assumes that it will introduce some methods in the future. Okay, let me write it down. So in the future, it is expected that some new methods will be introduced. Will be introduced. Okay, so that's why if you even at this point over here, if you try the following declaration, for example, if you say B, some objects is assigned to, let's say new, and then A. Let's say we just got the default constructor. So this one here will not actually compile. It's actually not valid. And some common misunderstanding is, at the moment, we actually don't have any new methods in B. So why can we not actually substitute A for B? Because as far as A, B are concerned, they both support MA. MA is simply just inherited verbatim into B. But even if you try to override the MA in B, even if that, okay, let's say here, for example, you might just redeclare void and then MA, and then you just try to override it to something else, even if that. As far as the expectation currently is concerned, A and B seem to be having only MA, but that's not how the compiler is considering. The compiler is simply considering the fact that in the future, like what you said, in the future, at some point, the descendant class should be introducing some new methods. Otherwise, what's the point of having these descendant classes, right? So that's why this will still not be compiling. Do you think that can answer your question?
Yeah, that answers it perfectly. And just one more thing I had
Yeah.
is when you're talking about the expectation of B and A here,
Yeah.
are we restricted to non-private attributes and methods, or are we including both private and non-private?
Okay, very good. So I would say typically when you say expectation, I would say the better way to think about it would be officially, I mean formally, it should be only the public. The public methods, let's say, because for this course, we actually said for any attributes you want to declare in the classes, they should be either private or protected if you want the attribute to be inherited to the subclasses, right? However, when you say if the expectation is only about public methods, that would be the official definition. However, public methods in turn might depend on the private or protected attributes, which depend on private or protected attributes. So what I meant was, for example, you can see over here, let's say when you are trying to define the implementation for MA over here. So definitely you have to refer to some attributes that's actually declared in A over here, which can be either private or protected. Similarly, let's say when you try to override the MA in the subclass B, you have to either refer to maybe the inherited protected attributes from A, or you may have to refer to some new private attributes you declare. So I would say formally, it's only depends on the public method that you can invoke as a caller on the class. However, you know that the public method itself may also depend on other private or protected attributes. So in total, you still have to consider all of them. That makes sense?
Yeah, I think so. So like if
Okay.
A had say like 25 private attributes and then B had 5, the compiler would still say that B has a bigger expectation because it's expected eventually B's expectation will surpass A.
Exactly. So as for, let me add a little bit more to what you're saying. It's a very good question, actually. I found that it's if you really are thinking about that kind of thing, that means you really dive into the issue. As far as the compiler is concerned, they don't really just compare the list of attributes and methods in one class and together with to make sure this might be a sublist of maybe the attributes and methods in the subclass. That's not what they do, right? So as far as the compiler is concerned, as long as one class extends from the other class, then that means at some point in the future, as we agree, that at some point this subclass will have strictly more expectation, like a public methods. That's something the compiler will consider. Otherwise, maybe in the beginning, if we say B has no new methods than A, in that case, we just consider A and B to be substitutable. In that case, we simply say, okay, for now, this substitution will just be okay. But at some point later, if I modify my code for B, let's say if I introduce another method, maybe MB over here, in that case, suddenly whatever that used to compile no longer compiles. So that would really create some confusion and inconsistency for the for the caller. So that's why the compiler since the beginning only consider the subclasses eventually will actually get strictly more expectation. So that's kind of the rationale.
Thank you. That makes sense.
Okay, very good. All right. Guys, any follow-up to this question here? Mainly just about how to understand about the expectation. In short, whenever we talk about expectation, it's really about in the long term, right? In the long term, at some point in the future, we definitely expect the subclass will have strictly more expectation than A, even if temporarily they may be just equal to. But that's okay. That's not how the compiler consider whether a line of code should really compile. Okay. Okay, very good. I think there's only one question I checked right before the session. There's only one kind of similar. Okay, so the question was about just about dynamic type and also dynamic binding issue. Let's read the question quickly, right? I think the first paragraph over here, your fellow student was just showing some understanding about the subject. Let's go over them. I think it's a pretty good summary, except for one minor detail. Your fellow student know that we can only call the methods that are within the expectations of the static type. That's very precise. That's precisely true. Okay, and methods that are not part of the expectation of the static type cannot be called unless we do some casting. All right. However, I want to be a little picky here. Whenever, let's say this, right? Let's just go back to the example we are familiar with. Usually, if you actually want to be able to call more methods, you only do downward casting, right? Remember we mentioned that in the lecture, whenever you do downward casting, you're basically widening. You're trying to increasing the expectation, right? Let's say use our familiar with example. Let's say we got our students over here, and also over here, let's say resident students, right? And also non-resident students. You can definitely draw the same conclusion for the more complicated type hierarchy like a smartphone. Let's now say this. If I have, let's say, students over here, let's say S, which is a new, let's say, resident students, right? And maybe the name over here. Now, we know that the expectation for S is determined by the static type students, right? So that means we can only invoke a student S dot maybe courses, for example, right? Remember the table that we did in the lecture. And specifically, if you say S dot premium rates, PR, so this will not be allowed, right? This will not be allowed. Even though the dynamic type is actually resident student, we said that it's an undecidable problem for the compiler to tell, okay? And so that's why I want to cross out about upward casting over here, because in order for me to call this PR, premium rates, get premium rate method, in order for me to do that, I need to do a downward casting, not upward, right? Whenever you do upward casting, that means you're reducing the expectation. So what we can do, you should really review, make sure you know the syntax. What we should do instead is to say S should be, first of all, cast into resident students, right? Let's do an anonymous cast. And after this, we can say the expression over here has the static type resident students. And then we can say dot PR. This will compile, right? We also spoke about what if, let's say, dynamically, if this is NRS, non-resident students. In this case, the cast will still compile, right? Because we're still doing a downward casting from students down to NRS. For example, if we put NRS over here. But in that case, oh, sorry, let me say it again. Let me be more precise. So this one over here is totally fine. Okay, you can definitely do that. Okay, what about number 2? It's not directly relevant to the question, but since I'm talking about that point, I want to review quickly for you. So how about number 2? Let's say we want to cast S into non-resident students. And then after the cast, we want to invoke some method that's specific to a non-resident student. For example, discount rate. Okay, so this one here, it will compile, right? The reason that it will compile is because you can see S has a static type students, and we are downward casting to NRS over here. So that's why it will compile. And this expression over here has the static type non-resident student. So that's why discount rate will be okay, right? So this one will compile. However, it's going to run into class cast exception. For the reason that the dynamic type of S, which is resident students, cannot fulfill the expectation for the cast type, which is non-resident students, because the resident students is not a descendant class of non-resident student, right? That's kind of the story we told in detail in the lectures, right? I just want to touch upon quickly. Okay, so let's now move on to your fellow students' question, right? So, okay, so now for example, let's say we got this particular assignments over here, variable assignments. So the static type is smartphone on the top of the hierarchy. And also iPhone 13 Pro is kind of down a little bit lower in the hierarchy, right? Under the iOS branch. Let's say we have this, meaning that this part over here is the static type. And this part over here is the dynamic type, right? And the question was, what would be the good use of the dynamic type if every method that we call should either be within the expectation of the static type, meaning that we can only invoke the smartphone expectation methods, what we should be casted. Okay, let me just illustrate this a little bit. For example, here, let's talk about SP, right? So if I say SP dot, I think that there are only 2 basic features you can actually call. One is dial, and the other one is SP dot surf web. Right, so both of these are actually okay, right? I presume you're already familiar with the hierarchy, so I don't need to show it. So these 2 are definitely within the expectation for the static type. And you just cannot actually say something like maybe sp dot, I think it's quick take, right? So this is actually not okay because sp has the static type smartphone, which does not have the expectation for a quick take, even though the dynamic type might support it. So that's why you have to do a cast, right? When you do the cast, you're going to cast sp into iPhone 13 Pro in that case, and then you will be able to call the quick take. Right. So your fellow student was asking, so in that case, what's really the point of having, for example, let's say here iPhone 13 Pro, if you really want to invoke the method, so why not only also put this part over here as maybe iPhone 13 Pro? I think that's what the question really was. So I just give you some ideas over here. I think there are several points to really mention here. One is about the overridden methods and dynamic binding, right? So what I want to mention is, for example, here you got SP, and over here, if you say SP dot dial or SP dot also serve web, right? Don't forget about the effects for dynamic binding. It's really important. So SP over here, so we know that its dynamic type is actually iPhone 13 Pro. So that means for these two methods, the version that's defined in the dynamic type will be invoked. So that's the use of the dynamic type, right? Even though statically it's actually a smartphone, but given that the dynamic type is actually something that's specialized, so when you invoke the method that's declared in the static type, dynamically it's actually going to invoke the corresponding overridden version that's defined in dynamic type, right? That's also something we said in the lecture. I'll write it down over here. So the overridden version of methods defined in the dynamic type, which will be iPhone 13 Pro, will be invoked. Okay, that's point number one. Okay, and also we got point number two and point number two here. So point number two is actually addressed a little bit also when we talk about the polymorphic collection. Okay, let me just consider this. Okay, let me use a different new page. So now I want you to compare these two arrays. Okay, consider these two arrays. One is, let's say, smartphone array. Okay, versus, let's say, another one, let's say iOS array. Right, so both of these are actually in the hierarchy for the smartphones. Apparently, this is like a descendant of that, right? So now the question is, which choice should you make when you implement your code? Should you choose iOS or should you choose smartphone, right? Let's now give some name to the array. So let's say smartphone array, okay? So this will be iOS array, right? Let's say we've got two arrays over here. You want to compare how these two arrays are expected to be used, right? One would be, for example, if you say smartphone array at certain index I, let's assume I is simply just valid, right? So you can definitely say dot dial. You can also say dot serve web for sure, right? Similarly, for the other one, you can also say iOS array, right? I'm talking about this array over here. Statically, every element is iOS. And then as a valid index I can say dot dial and also dot serve web. Okay, so both are actually valid, right? So they all can be expected on both arrays statically, right? But now the difference would be if you try, for example, say here, if you say smartphone array over here at index I, maybe dot FaceTime. Okay, versus if you say the other one, iOS array at index I dot FaceTime. Right? hopefully you can already see this one is not going to compile, whereas this one is actually going to compile, right? For the simple reason that the static type over here is simply just smartphone. So this is why the FaceTime is not just is simply not declared at the smartphone level. So that's why it's not going to compile, right? Versus if I try this one here, iOS array at index I, we know that static type as declared it should be iOS. So that's why it would be okay, right? The reason that I'm mentioning this is I want you to know that it's really a design choice about what the type of every element is for the array. You might choose a parent class, or you might choose a child class. Which one to choose is kind of up to you. You have to somehow vision, as you are using this particular array, are you expecting yourself to call more about the parent methods, or are you expecting yourself very often to really call the child methods like a FaceTime? If you're more often to call the parent version, in that case, smartphone should be enough. All right. If you're expecting to call the child method like a FaceTime more, in that case, to really avoid casting so often, in that case, you should really choose the child class. Right. Let me write it down. It's a very important design rationale for you to keep in mind. Okay. I think that's also mentioned in the abstract classes and interfaces lecture. Okay. So here will be the lesson. Okay. So number one. If the intention is to invoke the parent level or ancestor level, methods more often. For example, the dial and also serve web. Dial and also serve web. Then the static type of array element should be smartphone. Should be smartphone. Okay, so that's the first point I just mentioned. On the other hand, number two, if the intention is to invoke the child level methods more often. Okay, let me move these two guys maybe a little bit to the left. Okay, and I'll just finish this and I'll take you a follow-up question if you got any. Okay, I'll put it here. Okay, to invoke a child level more often, and the child level methods that we talk about, for example, FaceTime, right? Then the static type of array element should be the iPhone 13 Pro. There is no not really right or wrong about choosing this one over this, or the vice versa. But I think it really depends on your need. You want to really vision about in the future. Am I actually going to only calling these two methods that are already declared at the parent level? If that's the case, then definitely choose for number one. In that case, it should be smartphone array. On the other hand, if you really want to invoke more often the FaceTime method on the array element, in that case, having this is going to require you to do lots of anonymous cast, for example, or instance of check. In that case, it will be safer. You'll be more convenient if you actually simply declare the static type accordingly, right over here. Okay, any follow-up question to this? I think this one I'm just reviewing about polymorphic collection, which we spoke about in the lecture, right?
Yeah, I had one.
Go ahead, please.
If you did something similar and say you had an object that had a static type of student, but you assign it to a resident student object,
Yep.
and then within resident student, there's an overridden method, some random overridden method that accesses an attribute unique to resident student. Does that compile?
It will compile, yes, because let's say student S is, let's say, new resident students. Okay. Of course, you might have some name over here. Okay. So in this case, what's happening is dynamically at the runtime, S will point to some resident students objects. We got a common attribute that's inherited from the student class, right? It things like a number of courses, and also the courses array, and also the name, and etc. Right? So these are the common ones. We also got a unique additional feature, the unique additional attributes for the resident student. Let's say premium rates, PR over here. So this will be the structure for that object over here. Maybe premium rates 1.05, whatever. Okay, and statically, this variable is actually students. So this means you cannot access directly to the premium rates by calling upon S. So if you say S dot get, for example, premium rates over here, it's not going to compile, simply because as far as the expectation for S is concerned, which is students, you just don't have that, right? As far as the compiler is concerned. On the other hand, if I try to invoke, let's say S dot get tuition, which is what you just mentioned. Okay, so now two things you actually mentioned before. Number one, this will compile because the get tuition method is actually declared already in the student class. So it's definitely part of its expectation, right? As far as the static type is concerned, you can definitely call the method, but which version of the method that's going to be invoked depends on the dynamic type, which I'll speak about in the second point. Declare in the students class. Okay, just remind you here, this is the inheritance hierarchy, students, under which we got resident students, and also we got non-resident student. And we actually got premium rates, we got discount rate over here, and then we got get tuition that's already declared over here. And that one, if you recall, actually calculates the base amount. And this one here, get tuition, is simply inherited, but we also decide to override it, right? I'll put a star over here just to say it's over. I'll just say plus. That means it's overridden. Okay, and also get tuition over here for the NRS is also overridden. More precisely, the way we override the get tuition method in here is by using the PR, right? And also the way we override the get tuition in this NRS is by using the discount rate. Okay, so it will definitely compile, right? And then due to dynamic binding, the version of get tuition, right? You can see this method here. This version specifically is going to be invoked. All right, so does that answer your question?
Yeah, thank you.
Okay, good. I think also remember in the very end of week number 9's lecture, I also summarized about when should you check static types and when should you check dynamic types, right? Let's just take a look at that slide together. Okay, it's actually very important because during the test or during the exam, whenever you're not too sure about which one to really consider, that will be the principle for you. Let's take a look. Go back to week number 9, and then if you look at lecture number 5, okay, I think we should go all the way to the end. Okay, this one here. It's slide 89. Okay, so whenever you want to only consider whether or not Java code will actually compile, in that case, you only need to consider static type. You never consider dynamic type when you only worry about compilation. However, whenever you want to talk about the behavior of your Java code at the runtime, once you execute the code, which version of the code should be executed, for example? Or maybe will the cast that compiles run into some class cast exception? That's another common question you want to ask by using dynamic type. So these, make sure you understand these 2 bullet points. It's more like a summary of what we covered earlier in the lecture. Okay, so that's about the Google Doc and also some follow-up, about the this issue here. All right, any other questions related to lectures or other things? Anyone? Yeah, if you haven't got a chance to finish off the lectures, please do so. Hopefully the coming written test number 3 will give you a little bit pressure, right, to really catch up with the lecture. You still got a chance to ask me either tomorrow, 1 p.m., or you can ask me again maybe next Wednesday or next Thursday about questions. Yeah, I'll pause a little bit longer just to see if you guys got any more questions. If you want to ask me about Lab 4, that's fine too. But maybe if that's too specific to your code, we'll delay that to office hour. If you got some general question you want to clarify, you're welcome to ask about Lab 4, which is due next Monday. Okay, I'll pause and then to see anybody want to ask. Okay. Can I take silence as no questions? Can I do that? Okay, let's see. From Marco. What happens if someone tries to subscribe, but the channel is at its maximum subscriber? Okay, that one there was actually addressed. Let me show to you in the lab manual. Okay, let's take a look. The short answer is you should just let the array index out of bound exception to occur naturally, because you should have already fixed the size of the array, right? It's been consistently treated from all the earlier labs. I didn't change any of the requirements. Let's take a look. If you go to your lab number 4 instruction, okay, and then let's now go to the problem, the problem section. Okay, that's problem section there. And you want to refer to this paragraph over here, right? So if there's any mention, if there's any maximum capacity, let's say the number of followers, let's say the number of followers should be 10, right? If that's the case, then you should really set the array size to be 10. If you're trying to add the 11th subscriber, in that case, you should really run into some index out of bound exception. That's okay. I'm glad you asked. But please make sure you do that. That should be very easy to satisfy. I'm just trying to make your job easier by doing that. Okay. All right. Any other questions? Yeah, for your lab number 4, like before, I think maybe after the deadline is passed, I will also try to record maybe some solution walkthrough with you. I have seen quite a number of possible solutions to the problem by your fellow students. Maybe you are here as well. If you already spoke to me during the office hour, I think the solution you got is not really wrong. Programmatically, it still pass all the test cases, which is good. So you definitely get a credits, without losing marks by doing those. However, I really want to go over the solution with you about this lab. This will be one of the 2 labs that will actually do inheritance, programming exercise. I will show you the ideal solution by using the various ideas like a polymorphism, dynamic binding, and also casting. Right, casting if necessary. Also checking the instance off. That's something I will do in the solution walkthrough. All right, and that will definitely help you prepare for the programming test number 3. Okay. Okay, one question from Darren. Would I be open to answering questions about graduate school? Yeah, office hour, please. Yes. If you want to ask me about graduate school, yeah, definitely. Okay. Hey, although it might be a little bit too early for you to think about it, but if you want to ask me, no problem. Just come. Yeah, for those of you who might be interested in applying for graduate school, maybe in your final year, I just as a heads up, if you really want to apply, normally the deadline for fall admission will be around this time. For example, U of T. I got a few students asking me for reference letter, so their due date is about the end of this month. So typically they will let you know about the decision early next year. So if you think about if you later you want to apply for graduate school, you definitely want to get busy already writing up your research statement, personal statement, other things, applying for transcript, about maybe early fall. You should really definitely start preparing for the stuff, right? Good. Yeah, so Darren, let's carry that maybe in the office hour. So let's do that. Okay, guys, any other questions? Okay, I'll pause for one more short moment, but you guys might be just okay. But of course, if you're still behind the lecture, you still got time to catch up, right? It's never too late. I hope. Good. Okay, seeing no further questions from the chat or from your speaking, so I would say, how about we call it a day today? Okay, if you got any further question, please, I still got office hour today, 3 p.m. and feel free to come by. If you still want to ask a lecture related question, I still got a session tomorrow for the engineering side. That will be 1 p.m. You can feel free to join or just watch a recording. Okay, that's it. Please study in time for your written test number 3. It will be a very good warm-up as well for you to get prepared for the exam. I'll speak about your exam maybe a little bit later in the final week, just to let you know what you should watch out for. All right. All right, guys, thank you for coming and take care. And I'll see you either tomorrow or next week. All right, you guys take care.